Hello everyone, keeping continue our integration series. In this video, I'll do some integration problems. Those look like difficult problems, but they can be made easier through simplifications. So let's start with our first problem. So we have to find the integral of x plus 4 times x minus 3 dx. And we don't know any rule for integration, like product rule for integration. No, we don't have any, right? So what we can do in this case is we can do some algebraic integration, algebraic simplification to start with. So we can expand the expression first. So x times x is x square. X times negative 3 would give you negative 3x, and then 4 times x is plus 4x and minus 12 dx. And we notice that we get x squared. So negative 3 plus 4 is x, so minus 12 dx. And now this is what we can simplify, what we can solve. So we can write this as our three integrals. So integral x dx minus integral 12 dx. And now we know that integral of x squared, increase the power by 1, divide by new power, so x cube over 3 plus x square over 2, and minus integral of dx is just x plus c. So that's voila. So we got our solution. So the first trick of the trade is, so sometimes expanding helps. So you can multiply the expressions together, so you can do the foiling. So if you know the foiling method, right? So you just multiply the two binomials together. So let's take a look at our next example. So if we have integral of 4x squared minus 2 over square root of x over x dx. So we don't have really like integration, like quotient rule for integration. So again, in this case, since we know that the power in the denominator is less, right? The power of the variable is less, and also there is only one variable in the denominator. So we can write this as two rational functions of 4x squared over x dx minus integral 2 square root of x over x dx. And x cancel. So here we have 4x dx minus, so again, so we have x raised to power half and down we have 1. So when we simplify it, we get negative power of x left and dx. And now we know how to take the integral of x. So integral of x is x squared over 2, and integral of this would be, so just increase the power by 1, so it becomes positive half over half plus c. And now we notice that, so this half gonna flip up and it's gonna be 4. So we get, so 2x squared minus 4 square root of x plus c. Or you can write 2x squared minus 4 square root of x plus c. So that is our integral of the given problem. So sometimes you can simplify, so you can write in terms of different fractions. You can split the fractional functions. Let's take a look at this one. So in this one, so if we look, so it's an improper fraction, right? So, and we have x minus 1 in the denominator, so it's less degree than the degree of the numerator. So let's use the long division first so that we can write this in terms of something simplified version. So for the long division, we do the setup. So x minus 1 outside, so x cubed minus x squared plus 5x minus 5. So first we think of x. What should I multiply x with in order to get x cubed? And the answer is, we should multiply by x squared. So x times x squared is x cubed. So minus 1 times x squared is minus x squared. And then we subtract. So when we subtract it, so we notice that we get 0, 0. So we need to bring some terms down. So we bring 5x down. So now we think about what should I multiply 5x with in order to get 5x. So the answer is 5. So plus 5. So in this case again, so we get 5x and then minus 5. And actually we can also bring this negative 5 here. So because we're going to get two terms, right? So again we subtract, and by subtracting we get 0 as a remainder. So in this case, so this becomes, so when we divide this thing by this, so we get integral of x squared plus 5 dx. So this problem reduces to a simpler problem because when you do the division of the two expressions, so you get this as the answer. So now we know that integral of x squared is x cubed over 3, integral of 5 is 5x plus c. So that is our solution. So that's one way of doing this problem using the long division. Or other way is you can recognize that we can easily take x minus 1 common in this problem. So we can cancel that common factor, and then there would be no need for long division. So I'll show you that as well. So from the first two terms in the numerator, x squared can be common and you can write x minus 1 inside. From the last two terms in the numerator, so 5 is a common factor, so x minus 1 over x minus 1 dx. And then we notice that, so from both of these terms, so x minus 1 is a common factor overall, so we have x squared plus 5, so over x minus 1 dx. So x minus 1 and x minus 1 cancels out, and we are left with square integral of x squared plus 5 dx. So integral of x squared is x cubed over 3. Integral of 5 is 5x plus c. And we get the same answer. So either use the long division, or if there are any common factors that you can cancel out, do that simplification first. So basically the tricks of the trades are, like, sometimes the complicated looking integration problems can be made easier through some simplification. I hope you like this video. So if you like this video, hit the like button and subscribe to my channel. See you next time.